Hello everyone, today we're talking about orbitals, or at least we're continuing with the chat of orbitals. If you have not watched the first one, please, I invite you to pause this video, go back and watch the original video on orbitals, as this is the second part and this one focuses entirely on ions. Now, just a quick refresher, remember that our orbitals are following in a sequence of order. That being said, our ions happen to be the ones that we got those pluses and minuses from. Remember, we get those from our periodic table with our numbers that are up in the top. What do I mean by that? Well, if we're looking at our periodic table, remember our first thing that we do in the exam is put in our +1, +2, +3, ±4, -3, -2, -1, and a big fat 0. This is where I'm getting my ions from, and remember that we kind of need to place these with regards to our orbitals. But these are going to give us a bit of a hint as to how many protons and electrons our ions have. Remember, positive has too many protons and less electrons, where our negative have more electrons and less protons, hence why they are more negative. Now today what we're going to see is with our orbitals, if we start to look at how we're placing our orbitals and how something like an ion could impact these. Well, let's start off with oxygen. We know that oxygen is up in my -2 column. So what we can do is we write down oxygen as a -2. Now this is rather important that we write it down on our piece of paper because we kind of need to work out how many electrons we actually have. So what we do is we take our atomic number, in this case 8, we write 8 electrons, and we take away whatever the power is on top of our ion. In this case, it's brackets -2. Why did I put it in brackets? That way it would not get mixed up with this first negative, and we know that a negative and a negative makes a positive. So in this case, we've got 8 plus 2, which equals 10 electrons. So now we know if we have the ion of oxygen, we don't have 8 electrons. We have been given 2 electrons to help fill out our shell, which means we are sitting at 8 plus 2, which is 10 electrons. This means we now have 10 energy to spend on our lovely chart up here. How do we go about that? Well, remember, we go up before we go down. Fill up this level, progress up to our next level, going up and down, 1 and 2, 3 and 4. Now we reach our P level. Remember, our P has all of them going up first before we can come down. 1, 2, 3, 4, 5, 6, 7, 8. And this is where we would stop if we have a normal oxygen atom, but because we've got the ion, we've actually got 2 more that we fill in. This meaning that we have now filled up our shell completely and are matching that of neon, having 10. Remember, our whole purpose of these ionic numbers are to get back to this perfect column being our noble gases. We want to mimic them as best as we can, should we say. Now, how would we write this in our exam? Well, it's great filling it up like this, but now we would have to write it down. So we would first have 1 S. We've got 2 spots there. We then have 2 S and 2 spots there. We then have 2 P. 1, 2, 3, 4, 5, 6. 6 spots. And there you have your answer for an ion of oxygen. We'll do it a couple more times. So this time we'll look back at our magnesium from the previous lesson. Last time we saw magnesium was a 12. Well, if we look at magnesium on our periodic table, we know that the ion for magnesium is in the +2 column. So we end up having to take our atomic number, that 12, subtracting what our charge is, in this case our magnesium, so Mg is a +2. We know that because we've looked at our periodic table. Once again, +2, magnesium. And so we end up with a +2 here. Feel free to put it in the brackets, but positive and a negative make a negative. And so we end up with 12 minus 2, which equals 10 electrons. How would we place this? Well, we remember from last time, we go up before we go down. We then go up before we go down. 1, 2, 3, 4. Up, up, up. Down, down, down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if we did have a normal atom of magnesium, we would have those 2 additional electrons, but because the ion has given away those 2 electrons, we would no longer fill the 3s column. Moving on from this one, we look at, one more time, we actually have to write down our answer. So writing down our answer again, it would be very similar from the first one, 1s2, 2s2, 2p6. And if we look at that and compare it to our oxygen that we just did, you will notice the answers are exactly the same for those 2 ions. But as we said last time, the tricky ones tend to be our transition metals. So let's go back to ion and we have a look at this one. Now, once again, ion, our transition metals have a bit of a trick to them, especially when it comes to subtracting or multiplying. Now, if we were to take our ion atom, ion here, we could get an ion. For this one, I'm going to use Fe2, so that means it is Fe in the +2 column, which means we would have to take our atomic number of 26, subtract that +2 to equal 24 electrons. Now, if we've got 24 electrons, that means we've got 24 that we can span out here. If we look to the previous version of our iron atom, we notice that we went all the way up into the 3D column. This is similar for our ion, because in the case of this one, we would progress as normal, going up and down, up, 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 and down, 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 up, down, up, 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 down, 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 filling up all of those spots. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, and now have, from 24, 6 spots remaining. Now, in the case of an ion, we know that our progression should have gone, well, if we would do it normal ion, we'd have to progress up to 4s. But in the case of an ion for iron, tongue twister, lovely, we actually have to take away from somewhere. Rules are simple with this one. If we're taking away electrons, we cannot take them from a lower level, which means if we're looking at our orbitals, we've still got to consider that 3 is still level 3 and still before level S of 4, which means if I'm taking any electrons away, I have to take them from our highest level and not a lower level, which means if I'm taking away 2 electrons, I cannot take them from 3D. I have to take them from 4s. So what we would progress to do in this one is, now we've only got 6 left, so we've got up, 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 down. 1, 2, 3, 4, 5, 6. We can add those to the others to make up our 24, meaning we've got nothing in 4s. Once again, I will point out the difference between our ion, which is missing 4s because we've had to take 2 away from somewhere, and 4s being a higher level than 4d, we've taken it away from there. Whereas if we had a normal atom of ion, we would have progressed from 2,4s first before going on to 3d, and that's where it gets a little bit complicated. Once again, we do need to write this down, which means we can do the shortcut. So Fe, we look at our periodic table, we see which is the most nearest or previous noble gas. In this case, it was argon, so we put our brackets, AR, close the brackets. Remember, our P is our level for noble gases, so anything after 3P, being argon, we would need to put down. So we would have 3D, 1, 2, 3, 4, 5, 6. And that's it. Your answer made easy. If you got any questions, please ask them in the comments section. Always love to hear from you. Hit the like, hit the subscribe, and I want to thank you for today.